What do you think? What do you think? What do you think? Give me your opinions. This study's, I think this study's great because it has certain things I think that are great and certain things that I think are a little bit suspect. So you tell me something either that you thought was great or suspect. Michael, go ahead.
Well, one thing that's suspect is they took two entirely different populations to study.
Go ahead. Tell me who.
Well, they took American women of unknown diets, unknown differences in diet, unknown, and then they took women from China.
Actually, these are all from China.
Are they all?
Case control study was conducted in Southeast China between 04 and 05.
Yeah.
So you got all Chinese women.
Oh, yes.
Okay.
Yeah, that's okay. That's okay. That would be suspect, though.
Okay.
That would be suspect because there's too many confounding variables in that point, if that were the case. Thank you, sir.
The difference, which is 4 to 5-fold lower than rates typically found in developed countries.
So maybe that's what you're talking about, Mike.
That's exactly
But
right.
isn't that what's going to motivate the study?
Right.
That's going to motivate the study because you have rates that are lower. And why do we care about breast cancer?
Because it kills
Only because I believe is it heart disease or breast cancer is the highest killer of women.
Highest.
Heart disease is the highest. Breast cancer is, I believe, second highest killer of women. So we care about this. Susie, go.
Well, what is self-reported?
Boom. Did you catch that? This self-reported instrument. Back to what I was talking about, Michael, earlier. Be careful with that. Again, caveat, timeout, caveat. In this class, when I give you data, assume it was collected correctly. But in reality, when you see that, warning flag goes up. Warning flag goes up. Go ahead. Good. Just something else to say, Susie. Or was that
No, that was it.
self-reporting? Yeah, that's definitely a red flag for me. Darla, go ahead. What were you going to say?
The sentence states that 1,090-year-olds were healthy women randomly treated from breast disease clinics.
Sure.
Why are there healthy women at breast disease clinics?
Because they're being checked.
Oh, gotcha.
Essentially, they're trying to be preventative. I just think it
Curveball.
Get the rest of my teeth going back. There we go. Curveball. So yeah, I believe that's the point is we're going to track them, and they track them for.
But it says they were confirmed with breast cancer. Yeah.
Healthy women from breast disease. Hang on a second. Potential control groups if they had a previous diagnosis of either breast cancer or malignant disease. Careful. The 1,000 experimental ones had breast cancer. The other 1,009 were healthy. So what they're trying to do is they're trying to see if breast cancer is impacted at all, whether frequency of occurrence or decrease of symptoms by green tea. So you kind of need a control group and an experimental group. You're right. The first 1,009, I find it interesting. There's 1,009 and then 1,009. Although we did lose some. Did you catch that?
Yeah.
We lost about 1.2%. That happens all the time. People just stop coming. That's actually pretty low. Losing 10 people out of 1,000 is not that big of a deal, honestly. So yeah, it really is.
It was to those people.
Well, no, you're implying that loss meant they died. Loss can mean they just stopped coming to the study. I wasn't thinking too morbidly, although you're correct. That's kind of a terrible thing to insinuate, and I apologize. Does that make sense, Darla? Susie, is that you fair? So basically, you want to have both because you get a more robust study that way. Go ahead, Jamie.
That seems weird if you're treating people with cancer already to see the preventative effects.
The idea is that this is the only variable different. You're trying to minimize the other variables by only focusing on the presence or absence of green tea on that cancer rate. But that's one of my issues with it. How can you control for that if these people are coming into a clinic, you're checking them, and then you're letting them go back out in their lives again? Who's to say they're not doing something else? I mean, what else could possibly impact breast cancer rates? Diet, other smoking, diet. I mean, one of these things I've heard over and over again in Chinese culture, fast food is becoming way, way more prevalent now than it was even 20 or 30, even 10 years ago. Driving versus biking. When you look at a picture of Beijing from 1970, bikes outnumber cars. That's flip-flopping now. So lifestyle other than green tea consumption. So yeah, I mean ostensibly you're minimizing everything down to one variable, but that's ostensibly, maybe not literally or 100% accurately. Go ahead, Bob.
They said they tried to, like I was going to say maybe where you live or where you work.
Right, but go ahead.
They tried to, in their lifestyle, I assume,
Yep.
it says diet and lifestyle were collected.
Yep.
So
Using
they
a
tried
validated
to-
and reliable, so they tried to minimize those factors.
Right.
Totally. They tried to minimize those factors as best they could. So all the questions you guys are bringing, and the concerns you guys are bringing up, keep them in the back of your mind when you take your research methods classes. That's when you learn how to deal with all that. Only because we need to kind of force the data, if you will. I want to interpret their results. Now, those of you are going to say, some of you are going to say, wait a minute, you're going to get results on crap data. That's where you take an entire class called research methods to discover if the data is indeed crap. You'll go find, I gave the sources to you. You got all the sources right here if you want to go track the study down. You can actually get more. I diluted this down to a couple paragraphs just to focus on what we're focused on. But just realize that there are questions that need to be answered that can't be answered in these couple paragraphs. So I encourage you, go check the main source and track her down. I tried to find ones that weren't actually in the databases. You can actually do them through Google. Okay, what is this study trying to show? There we go. So, in other words, somebody asked me about stating your null versus research hypothesis earlier. That was a great question. We're going to answer it right now. So, in other words, I want to know what H1. It's either H1 or HA. Sometimes it's called HA for alternative. I think your book uses H1. I can't exactly remember. HA. Is HA. Your book uses HA. Okay, so we can change that 1 to an A. That's totally fine. You'll get used to it. Let's come over here. H for hypothesis, A for alternate. H for hypothesis, A for alternate. What is the research study trying to imply? That somehow
Green tea prevents breast cancer.
right. I'm gonna make a very, very nice, correct statistical statement. Green tea consumption is correlated well with reduced breast cancer. Now, do you see the difference between saying it that way and saying that green tea cures breast cancer? This is a correct statistical statement because it doesn't rule out that even though it's correlated with it, it might not be the cause of it, just because it's correlated. And the study actually says just that in the last sentence, I believe. It's showing a correlation between breast cancer consumption and decreased breast cancer rates. It doesn't mean that it's causing it, but if you look at the back of any box of green tea, they're constantly talking about the catechins and the flavonoids in breast cancer, or cancer, actually not breast cancer, but cancer in general, reduced cancer rates in general. So they're playing off of studies that are done like this, and to believe that it's somehow better for you from that point of view. Yeah, Mike.
Well, and I mean, realistically, if you look at it, just consuming green tea doesn't necessarily mean that that's what's actually causing you
Exactly.
It could be that extra glass of water that you're drinking.
It could be the extra mile you walk as opposed to driving. I mean, there's all kinds of, but the correlation allows for those other variables.
Yep.
If we don't say causes, we say correlated, we're playing it safe. What's the null hypothesis therefore going to be? And that's usually called H naught for null. That it's not highly correlated, not well correlated. So green tea consumption is not correlated well with reduced breast cancer. I think you can get the acronyms. You see how they're opposites? They're opposites. This says they are correlated well, that says they're not correlated well. We're not going to prove anything with this study. What we're going to show graphically here momentarily is which one we should believe based on the results from the study and why. We're going to get a likelihood. That's what this class is all about, likelihoods. Measuring the chance effect, measuring the likelihood that the data that we got either agrees or disagrees with what we're expecting it to do. Which one do we want from the study again? We want that one, right? We want the correlation that shows green tea is highly correlated with reduced breast. We want that, of course. We want that, of course. Okay, so here's the results. And again, I love every single point that you guys brought forth about questioning the data in the study. Good. For every single point you brought forth, I love them all. I do. But let's not focus on those, although you will in research methods classes. Let's focus on the data and this. Green tea, oh, thank you, Jared, yes, thank you. Excellent, my friend. Green tea consumption was associated with a reduced risk of breast cancer with a statistically significant test for trend. So trend, we'll study that more in this class as we go on. That's a bivariate. So basically you've got an X and a Y coordinate, a scatter plot. Imagine a scatter plot. You've got amount of green tea and breast cancer rate. We'll do this. We got a whole project devoted to this by the end of the course. Look at that p-value.
Oh.
Is it less than 5%?
Yeah.
Yes, it is. It is less than 5%. It's 1 in 1,000 versus 1 in 20. That's 50 times less-ish. So here, This is your null curve, your one-sided 95% confidence interval for either cancer rates in the general population or elevated cancer rates. Okay? These are slightly lowered cancer rates. Slightly lowered. Now, slightly lowered doesn't mean statistically significant. It just means that they're hiccuped under normal. But it's like saying I flipped a coin 10 times and I got 4 heads instead of 5. Is that an unusually low number of heads? Probably not. That's well within the hump of the bell curve, so to speak. What if I get 3 heads out of 10? Would that be unusual? What if I get 2? What if I get 1 or 0? What if I watch Max put his Crocs on 10 times and he only gets them on the correct feet 1 time out of 10? Is he guessing? Is he guessing? No, he's not guessing.
No.
He's not. If he was guessing and he puts them on 10 times, he should be landed right here. 5, 4, 6. What's that?
He put them on wrong.
He put them. Well said, Jamie. I believe he put them on wrong 1 time. He put them on the wrong feet 1 time and the correct feet 9 times out of 10. Well said, friend. So this is what's happening. Here are your usual cancer rates. Slightly elevated, very elevated, slightly lowered, exceptionally lowered. How can we tell we're down here at the exceptionally lowered cancer rates? Michael, you look at the right thing.
Yeah, it's their p-value.
That guy. When that guy right there, when he falls below 5%, you know you're outside of your margin of error of what you're expecting for cancer rate. Now, notice how it says usual or elevated? Usual or elevated. That's all wrapped up in this statement. Because remember what the research hypothesis is? Green tea consumption correlated well with reduced breast cancer. What's the opposite of reduced?
The same or higher.
Increased or the same or higher. All of those are indicated on that bell curve, aren't they? Same or higher. Now, please realize the loose way I'm defining the word same. This is considered same, right? Significantly higher would essentially be this area on this side. And imagine the furor that would come up if a study was done. And instead of getting a p-value of 0.001, we got a p-value of 0.999. Oh, what would that imply?
Never want to drink green tea.
That would imply we're over here, which means not only can we not, we're still going to get the same result. We're going to say that green tea cannot be shown to lower breast cancer rates. But we just discovered that it appears that green tea increases them. In which case we say, wait a minute, that's one study out of hundreds that have been done that show exactly the opposite. Maybe that one study is what?
Wrong.
The outlier.
The outlier, the wrong study. Exactly. That can happen. That can happen. Go ahead, Susie.
So the smaller the p-value is, the more significant.
Yep. The smaller the p-value, the more significant. But here's the deal. Because of random sampling error, which is good, it's a good thing, it happens within samples, you can't run this study twice and say that if that one comes up p less than 0.001 and another one comes up p less than 0.005, you can't say this one's 5 times more significant. They're all less than 5%. We're using that as an arbitrary cutoff. So just, rather than looking at a multiplier for p-values, did it go below 5% or not? Make it binomial. Much easier that way and much more correct that way. Fair? Great point, my friend. Great point. Now what I want to do, I want to focus, again, back to this. Okay? We got our lower breast cancer rate data, which we did, right? We got that. That's what we got. But we were expecting green tea to have no effect, weren't we? Because remember, when you want to show this, you go in by assuming
The opposite.
Yeah.
that. So you go in assuming this, but your data comes back the opposite of that. So these guys are contradicting each other, which is indicated by that very small number right there. So what do you think? Does it appear that green tea is associated with lower rates of breast cancer? Yes, that's why you're reading the article. That's why you're reading the article. If the article came back inconclusive, then you're like, oh well, try again. Or not. Or maybe we just stop trying to make green tea do magic. But these studies keep coming back and keep coming back and keep coming back. The problem I've seen most of them is they mostly are done in Oriental populations. American populations are wanting for this. I want to see some more done in America because there are so many other lifestyle differences besides green tea consumption, dietary consumption, exercise levels, all kinds of things that Americans suck at. I mean, let's face it, we kind of suck at taking care of ourselves. I'm a textbook case of this.
Yeah, but it's not just that, it's African Americans.
Okay.
Land, nutrition class.
Yes.
Remember with salt,
Salt, okay.
it raises
Blood pressure, yeah.
Now with African Americans, it can raise it 15 to 20%, but with whites, it might raise it only 1 or 2%.
Oh, interesting.
So ethnicity.
Interesting, there's a genetic marker somewhere.
So that's the first thing, my wife is Asian, but that's the first thing I look at, I said, okay, you can't go by.
There's a cultural difference that might be genetically linked somehow.
Genetic.
Good, which is not really measured here. Although the results are good for Asian population, they might not correlate over to an American population. Bob, go ahead.
I was gonna say the same thing, it would have to be another homogeneous
Yes.
population, like, Scandinavian.
Sure,
French,
sure,
yeah,
sure.
because there's too much of a melting pot.
Absolutely, that's true, that's very true. That's very, very true. Look at more homogeneous, that's good. Ashley, go ahead, what are you gonna say?
I was gonna talk about another Scandinavians are predisposed to having MS
Interesting.
and other,
Has that been replicated? Do you know if the study's been done a number of times? Or if studies have been done a number of times? See, the thing is, I read an article years ago called The Truth Wears Thin, or The Truth Wears Out, or The Truth Falls Apart, or something like that. And they showed a bunch of studies that were shown to be overturned. So a study's done one time, and then it gets overturned. And the article was like, what does statistics show us? I'm like, statistics shows us that 5% of the time you get wrong results. So, if you're showing me 20 studies, then I'm thinking there's at least 20 times more done every year that show me the true results. So I would expect some to come back wrong. That's why I asked for replication. If it's replicated over and over again, then I believe that there's probably something there. Because the chance of all of them being wrong, as you saw from your exam, take-home exam, the chance of all of them being wrong is essentially 0. So the chance of at least one of them containing the true value is basically 100%. The chance of all of them being right is also basically 0. But the chance of at least, you said the idea of replication is that you increase the confidence, or I shouldn't say that, you increase the belief in your stated results. Let's come back to this if you don't mind. Jared, go ahead, Jared, go ahead.
So I'm maybe a little confused. If you're looking at taking this study and doing it on a Western population,
Yes.
say the United States,
I'm saying it has never been done. I've never seen one.
but we're saying that it doesn't hold true. But
I'm saying I don't know if it holds true.
But
or
if we
not.
had 1,068 people and it was truly random, couldn't we make the assumption that it's?
Yes,
Okay.
as long as you've done the study correctly. Yeah, there's no reason to think it has to. Yeah, totally. Okay, so here is what I was getting at before, when I think it was Jamie that brought the point up. I can't remember exactly now. I think it was you about the outlier. It's in the text, doesn't matter. Here, this graph right here is essentially the same graph you were just looking at on the other slide. So this is the non-greeting, it's that. I can't say it right now, apparently. It's what that says. So remember where we fell on that curve. We fell far to the left side, had a p-value of 1 in 1,000, or less than 1 in 1,000. So the belief is that that was outside of 2 standard deviations, outside of a margin of error of the confidence interval, which means it probably doesn't belong in that curve. So the belief, therefore, is it more likely to belong on this orange curve? Is it more likely to belong on this orange curve?
Yes.
Yeah.
Well, I think so, because the measure of likelihood is how tall the curve is. Remember this from 243, think of your xp of x column, right? xp of x. The bigger a p of x is, the more probable. So there's the probability, if you will. I'm being a little bit incorrect here. The probability is technically that and everything shaded down, technically speaking. But just look at the height. That's the chance you're in the gray curve. That's the chance you're in the orange curve. So this orange curve, that red dot actually belongs to the, if you will, the big middle part of that orange curve. Which means I'm thinking maybe we believe, based on this study, that, assuming it's a controlled study, everything's been controlled for, all the variables have been controlled, there's green tea drinkers' breast cancer rates, on average, are actually going to be lower than the general populations, which means that that red asterisk that was on the other curve that didn't belong, belongs somewhere else. And the somewhere else that belongs is a bell curve shifted down. How far? I don't know. I don't know how far. That is a tricky question which we'll revisit in this class over and over again. I mean, on average, it should be centered right on that data point. But that data point is going to fluctuate with every sample that you do. So for right now, let's just say we significantly believe that it's lower than the general population. Go ahead, Michael.
You answered my question.
Oh, did it? Okay, good. And that's the idea. I don't know how far down that is. This is why false negatives are so amazingly hard to calculate. And we'll come into that in this class. We'll deal with that in this class. But this bad boy right here, there is a significant difference. In other words, you've got your two confidence intervals right now, and they're not overlapping. I know the tails overlap. I know that. But a confidence interval chops off. The tails are ignored. You're in the interval. So what you're seeing here is you're seeing two distinct confidence intervals, two separate tanks. There's a tank that is the breast cancer, excuse me, that is the non-green tea consumer breast cancer rate, and then you've got a tank that is the green tea consumer breast cancer rate. So the question is, well, we just answered that, didn't we? If you observe that red asterisk, is it more likely orange curve or gray curve? Obviously orange curve. So based on that, friends, do you believe that green tea is having some effect on breast cancer? Now, we have to make a big assumption, assuming we've controlled for every single other variable, which is arguable, as Jared pointed out before. But based on that assumption, we can believe this. Because this guy right here is that orange curve. I don't exactly know where the orange curve is, but I know it's south. It's less than that curve. Fair enough? Ish? Get there? Good, good, good. Let's wrap up with one more. The secondhand smoke article. And we're not going to finish this whole thing today. I want to come back and talk about false positives and false negatives tomorrow. But let's read this secondhand. It's a shorty. It's a shorty. Wait, not much to it. Just to drive the point home. See if you can figure out where the study was done, too, while you're at it. Any ideas where the study was done?
Greece.
Look at those last names. And first names for that matter. Except for the random Italian 3 in. We got a Greek study. Awesome name. Statios. Adrianis. Those are beautiful names. I'm murdering you. I apologize. So we're done in Greece. So again, we have a problem with homogeneous populations. We're looking just at a Greek study. Is that a problem? Is that not a study? I don't know if that's a problem. I have no idea if there are markers in the Greek population versus markers in the American population. But that's something we have to consider. In research methods classes, we'll do that. Any concerns about this? We're measuring secondhand smoke and lung function. Jamie?
This is so not controlled.
How? How so?
It's at the setting, the secondhand smoke setting is at bar restaurant level.
Uh-huh.
What the hell does that mean?
Well,
How big is the bar restaurant? How many people are in there smoking?
good definitions that need to be defined, right? What is it?
There's pretty significant difference.
And my friend, please remember, I gave you a link. There's way more detail than what I put here. All the methods is listed out. I just didn't want to print 8 pages for each one.
Thank you.
So for sure. Because although I love when you guys pick on the method, and I encourage you to always do that, I don't want to get too hung up on that because, like I said, you have an entire class devoted to that later. I want to focus more on the results and how we interpret those results. But thank you, that's perfect. Perfect. Michael?
Well, one concern is that where your population is located.
Yes, of course.
In Greece.
Potential population, go ahead.
Absolutely, because in Greece, quite frankly, I'm not sure that the pollution levels exist the same as they do in LA.
Gotcha.
So.
So a confounding variable perhaps would be environmental issues. I think Greek, I think of the shorelines, the beautiful waves lapping up, Roman ruins, wind, breeze, torches, marble statues without arms, things like that, right? And then you think of LA, you think of clogged-tail pipes, you think of, who knows? Another environmental factor that might not be well represented or not well represented in this study. Good. Jared, do you have something? Go ahead. I thought I saw another hand go up. Go ahead, Gene.
I just realized there's no mention that these are non-smokers or smokers.
That's not mentioned in the diluted part down that I've got. I encourage you to check out the actual, go ahead, Susan. Oh, non-smoking adults, we got this.
And they're all.
Yep, there it is, 16 non-smoking adults,
But they're.
8 women.
Okay, gotcha.
But they're all what, go ahead.
Never mind.
So we got
Now I see that it's
16,
8 women.
Half and half,
Got
we
it.
got the gender. Anybody concerned with 16? Kind of small. It's kind of small, you have to accept a pretty large margin of error that way, but we have tools to deal with that margin of error, even with a large margin of error. We have tools, we have many tools with even smaller data sets. Susie?
What does crossover mean? It says a single blind crossover.
Oh, hell. I used to know this. I believe it's when, so it's a single blinded, which means the person getting the treatment doesn't realize what they're getting, which is kind of hard to realize, yeah, smoke in a bar. But the idea, I believe, is in lieu of a control, I could be completely wrong about this, in lieu of a control group, you've got a baseline measurement, and then you expose them and then take them back out of the exposure to smoke, and you measure them along the way. So you're basically essentially crossing in from one to the other. I think, I could be wrong about that, and I don't remember what that term means exactly, but I think that in lieu of the control group. You're measuring the baseline, exposing them to smoke, measuring them again, then letting the smoke, if you will, filter out of their body, and then measuring them again. And we'll play with this tomorrow, we're running out of time today, but I believe that's what it is. I can find out, but I think that's it, in lieu of the control. Anything else? Ring the bell.